Everybody, it's Jeff. We're going to do CS161A. We're on week 8, which is loops part 2. We're going to continue our learning around loops, following kind of our same bit using the replit sandbox for the majority of this session here today. Reminder: what we're working on here is module 8, which is chapter 7, discussion 7, and assignment 7. And you can see the dates and so on in there. Okay. The textbook here for chapter 7. We're going to talk about some more details on loops here. We're going to talk about nested loops, break and continue, and a few other things. There's actually not a lot of specific new content in this module. It's just more of a little bit of strengthening the knowledge of the loops from last time and some more examples. So remember, a while loop is run 0 or more times as long as a condition is true. The do loop is run 1 or more times until a condition has been met, or 1 or more times while a condition is true, right? Or while a condition is true. You can word those either way. And then the for loop, run a set number of times based on the parameters in the for statement. Those are our 3 things we've done so far. I'm going to paste those into my comments here so that you have them in the file that we'll upload here. And so before we get into an example on the loop, let's just remind ourselves of some things around strings. So let's declare a string. We'll set that to some value. And just a reminder here, to get the size of the string, we use this function where basically we say the size and we put it after the variable name, like that. To get a character at a position, we use the at command. And remember, we start at 0. Remember, we start at 0. Last character in text.at. And now we're going to put here the size minus 1. Because we start at 0. Remember, we start at 0 and end at size minus 1. And yes, I said start at 0, and I keep saying start at 0. It is one of the most important things that we have to remember. And as you program more and more, this will become more drilled in here. So let's double check. Size is 6. 1, 2, 3, 4, 5, 6. That's good. A is our first character, and 3 is our last character at size 6 minus 1. At position 6 minus 1. Okay. So now let's create a loop to run through every character of the string. Okay, so to run our loop here, we're gonna use a for loop. We're gonna go set I is equal to 0. I is less than in text.size. This matches what we just did, right? Not a comma. And then for each character, we're going to print out that character, run through the two upper, make sure our parentheses match. Replit does it for us, but I like to double check sometimes. And then we need to print out an end line at the end. Okay, so if this works, let's see if this works. I'm going to enter you can see what it does is that every lowercase character gets capitalized and everything else stays the same. And so what two upper does, you might remember, is if it's a lowercase character, it converts it to its uppercase equivalent. Otherwise, it doesn't do anything with it. We can change this, by the way, and we can do to lower instead. And do the same thing, and we get the same result in the other direction. Okay, so that's, you remember in one of the earlier assignments, we asked the question, how do you run two upper on a sequence of characters or a string? This is exactly how you would do it. Pretty straightforward. Okay, one of the other things that I demoed a few weeks ago was the ability to do a search and replace on a string. So let's create a nonsense string that has a bunch of stuff in it. And we can use the find command to find the location of a substring inside that string. And you did this already, right? You did this when we did the assignment where you determined if the phrase 1 was inside phrase 2 or phrase 2 was inside phrase 1, or they were both the same or neither happened, right? You use this find command, or you may have used substring, right? You may have used, there's different ways to do it, right? So we can say first instance found at position I. Now we can do a replacement as well. We can do replace, and we can replace 3 characters at position I with, well, we'll do lowercase x here. Let's see what happens here. We can say our updated is in text. Okay, so let's run this. You could see that it found the first instance at position 5. So remember, we counted 0, 0, 1, 2, 3, 4, 5. And now we've replaced those 3 capital O's there with lowercase x's there. So we learned that before we learned loops. So now we should be able to put together what we've learned to now just figure out how to replace all instances of this. And so I'm going to reset my string. And now I can do this as a while loop. And I can run the find command inside the while loop. And so remember that the find command returns the position of that substring, the first position. And if it doesn't match, it returns this reserved value called npos. Okay, and so what we have to do is we simply can say, while while the result of the find command is some number other than a non-position, that means we found a version, and then we need to get the position of it, of course. So we got to run that find command to get the position. And then we replace it like I did before. And we'll put a print statement in here so that we can keep following. And then when we get down here, we should be done. Okay, so I can actually remove all this. We don't need all this. Okay, let's run that and see what happens. Okay, so you can see that there we go. You can see that, each time we run the loop, that's the first, each time we run the loop, we get rid of one of these substrings until we have none left. Okay. A little bit inefficient because I run this find command twice. So there's ways to do this, right? There's certainly ways to do this. You could, we could change this to be while true. We can then select, we can do the find if I equals string and pos. We can break from the loop. Otherwise, we do the replacement. I think this should run the same. Let's see. And it does. So you have a couple different ways you can do this. You can use the do until loop. You can check before you run the loop. There's lots of ways to do this. Having this command in your code twice is not a big issue. I always like to watch for duplicate code, and when you have duplicate code, it is a sign of potential maintenance challenges. So always worth thinking about how you can reduce your duplicate code here. So that's a little bit more on the string functions. Let's talk about the concept of a nested loop. So often, as your programs get more complicated, you're going to need to operate on multiple sets of data, or you need to generate combinations, which is kind of it's an example of operating on multiple sets of data, or you need to do something in multiple dimensions. We use what is called a nested loop. So let's do an example of this. No, that's great. Okay, so what you see here is I have a for loop immediately followed by another for loop. So let's see what happens when I run this. Okay, fine. Come back to that in a little bit later. Okay, so let's see what happened here. I got a bunch of output here, a bunch of two-letter outputs here. And so when I get to line 22 for the first time, I is equal to 0 here. And then while I is 0, I run this for loop. And I run this for loop four times, or the code inside the for loop 4 times, where j is equal to a, or sorry, not j, the value of the string, right? The index of the string is a, then b, then c, then d. So what we could do is we could put we could put a instrumentation line here to kind of show that. And you could see that basically for each iteration of the outer loop, I run the full inner loop. And so this gives me my full 16 combinations of using A, B, C, and D in both of the first and second positions. So if you were building something in a grid, right, and you needed to check, every value of the grid, for a battleship-like game, or you're doing some mapping, or you're doing you're doing matrix math for those of you that have learned that. A nested loop is a common way to go through a two-dimensional grid. And this would be the way to do that. Now, sometimes the inner loop can be based on where the outer loop, where in the outer loop we are. So if I change this, instead of starting at 0, I change this to start at I. Let's watch and see what happens. So you can see here that I get 4 iterations in the outer loop, 4 iterations of the inner loop for the first run. Then I only get 3, then I only get 2, and then I only get 1. And so the difference between these two is here's all 16 combinations of a string that has A, B, C, D in the first and or the second position, whereas the second is how many different combinations I have where I have those 2 letters in a string of 2. In other words, if I already have AB, then I don't bother with BA. I don't care about the order. Sometimes you care about the order, sometimes you don't, right? So I already have AC, so I don't need CA. I could also change this instead of J equal I can do that, and let's watch and see what the difference is there. So I get even fewer, and this one doesn't work, right? Because what happens is I miss the cases where I'm missing, if you look, I'm missing 4 cases here. I'm missing AA, BB, CC, and DD. We would fix that by putting an equal sign there. And now I get my same 8 combinations, but I get them in a different order. Okay, so I'm going to go back and I'm going to do this one more time. Okay, and we'll make some notes here. Okay. So, well, here, we'll just do this. We'll just do this 4 times, I think, maybe. Maybe that's the easiest thing to do. Or 3 times, rather. Okay, so let me clear my console. I've copied the code 3 times, so I'm going to get the same 16 things 3 times. Ignore combos we have already found, not worrying about order. So we change this to, instead of going 0, 1, 2, 3 for each inner loop, we go 0, 1, 2, 3, 0, 1, 2, 3, 1, 2, 3, 2, 3, and 3, 3, or 3, right? So let's run that. Okay, so we get those. Now, ignore combos we have already found and combos with the same pair of letters, or the same letter twice. and that's where we got BA, CA, CB, DA, DB, DC. You could do this in the other way too, right? You could instead of saying you would do J equals I plus 1 in the other direction, right? And then finally, oops. And I like to show both because depending on your application, you might want to increment the first, like you might want to increment the first index first, like I do here. You can see I go A's, then B's, then C's, then D's. Whereas here I do the A, B, C, D first, right? You can kind of see the relative order of these two. Okay, so you get to play with this, right? The more you play with this, the more practice you have, and then the more, different ways you can come up with these examples. This is your kind of little quick demo of what a nested loop is. Nested loops are used, like I said, primarily when you're doing multiple dimension stuff, which for many of your applications will just be two-dimensional things like grids, game boards, tables, and so on. You can have nested loops. You can do 3, 4. You can do an infinite number of nested loops. If you're doing a three-dimensional thing, you'll need 3 dimensions. You'll need 3, and you'll do an I equal loop, and a J, and then a K loop, right? You'll also use nested loops on a single set of data for other types of applications. For example, you'll use them when you're doing sorts. Sorting is an example where you're running the outer loop and then the inner loop is doing stuff inside, right? And so it can get more and more complicated, obviously. All right, let's keep going here. I want to talk a little bit more about break and continue. We've demonstrated break a few times. I don't think I've demonstrated continue yet. It's a convenient way to break a loop. That's what break is, right? And so, for example, it's often used with a while loop where true is your condition, which means you run forever. Okay, so let me just demonstrate that. Run this code. And my code is running. You can see up here, it's running. It's running. We can come back tomorrow, it'll still be running. At some point, Replit will probably complain. And it will say, I'm done running. You've taken too much of my time. Okay, this is called an infinite loop, right? This loop is adding 1 to I. It's not doing anything with I. There's no exit condition for that. So we can simply do something like that. Now when we run, I kept it running. We ran for 43 seconds before I finally broke it. And so you can see that it ran. I started at 0. When it got to 5, we broke out of the loop. Okay. Now if you had something this simple, you would just write a for loop, right? But the point is, you generally won't. It won't be that simple here. Okay, so let's do a more detailed example here, right? So we'll create some variables here. So let's think before we do a specific example, right? So when do you want to use break? Right? You can enter data until a condition is met. Right? So you might want to write a program where I enter data over and over and over until I've met a condition. Right? Enter numbers add them all up together until I enter 0 to quit or something like that. Or no, that's that. Sorry. So a condition is that I want to enter numbers until I reach a certain sum, or keep entering numbers until I hit the magic number, right? Or you can enter data until the user says they are done. Right? That was what I said the first time. Or we can do input validation, right? I enter over and over until the valid number is entered. It's really the same as number one, but it's the same data versus lots of different data, right? Okay, so let's do an example here. Okay, so here's my contrived frequent flyer detection program here. We're going to enter trips until we hit our target to meet our frequent flyer total. We're gonna add some positive validation here. We're gonna use the break to show you that, right? If trip is less than or equal to 0, yeah, there's no negative distances in airline travel, right? Sorry, let's say end price. All right, so if you probably noticed here, we haven't used the variable target just yet, so we'll come back to that here. We're just gonna do a couple different things here. No. Oh no, never mind. It did. I'm sorry. I'm doing two things at once. All right. So yes, we did do that. All right. Where is an indel problem here? Listen up. Redirect there. Okay. So I'm going to enter 1,000 miles to travel. I'll enter 100 so far, and it did not work. No, that's right. Sorry. Getting ahead of myself. Let's start over here. Okay, we're going to set 1,000. 1,000. We've run 0 miles so far. I'm going to rerun that so that silly missing space doesn't bug me. Okay, so I'm going to enter a trip of 100. And why did it not work? Because I need to total equals total of trip. Traveled 0 miles so far. Oh, this is inside the while loop. This guy should be there. Okay. Yeah, what was happening is I had it here, and so it was never updating. So let's try it again. This time I think. Okay, there we go. So we'll enter 200, and now my total is 300. Complains if I enter a negative value. Complains if I enter 0. I'm at 500. I'm at 900. And then once I hit more than 1,000, it gives me that total and exits the program. Okay, so let's kind of make sure we see what's going on here, right? So I'm entering my total number of miles as my target, while my total, which is set to 0, is less or equal to target. I'm gonna just tell me what I've traveled so far. I'm gonna get my new value. I'm gonna make sure that it's valid. And if it's valid, I'm gonna add to it. If it's not valid, I'm just gonna stay inside this inner while loop, right? I'm just gonna keep going between 25, 26, 27, 28. But if the trip is valid, I'll break, which will pop me down outside of the while loop. That's what break does. And I wanted to show this example, right? Because I have a while inside a while. This break does not break out of both whiles. It only breaks out of the while we're in. And so you can get very sophisticated here. Okay, so continue is a similar mechanic where you can, instead of breaking out of the loop, you skip to the end of that current loop and you bounce back up. So we're gonna do an example of that, and I'm gonna just kind of modify the existing code here in place. Again, the file that you'll download has both versions, so don't panic if you feel like you're getting lost here. So it's the same concept. Instead of breaking out or exiting the loop, we just skip the remainder of the code inside the current iteration of the loop and go back to the top of the loop. So let's so what I'm going to do is I'm going to add a feature in this program to not include super large trip values. Okay, so I'm going to ignore basically super large trip values. So to do that, let's see. I feel like keep the same target, right? Okay, we'll do the same input validation with the break here. But here down here, we're going to say if trip is greater, we'll use if trip is greater than 200, large value being ignored. Not sure why we do this. Seems like a silly application, but we're going to try it anyway. Okay, so the only thing I changed in the code here was I added this code right here. So right before I update my total. So let's see if this works. Okay, I go 100, I'm at 200, again, negative values don't work, 0 values don't work. If the value 200 works, but if I do 201, doesn't work, right? It ignores it. My total still stays at 500. So when I ran continue, I basically skipped everything. Starting from here, I went basically to the top. I basically went to the top of the loop, which meant I skipped this statement. Okay. So a good example of where you might use continue, right, is if you're scrubbing some big long data file and you wanna bring in a bunch of things and you're doing a big group of data analysis, but based on some conditions of the files, you just want to ignore them. this is where you would use continue, right? So it's kind of the same structure, but it would allow you to skip processing certain things. Okay. My commentary on continue is we could have modified this. Instead of doing this, you could just do that, right? You don't need continue. You could just, if it's greater than 200, ignore it. Otherwise, else add. So it depends on the application. I don't use continue very much. I actually don't use break very much either, but I use break more than I use continue. Um, so in this case, it would be just as simple. But if this code was much more complicated, and you were using it in other places, and there were lots of different things that were happening, you could use a combination of breaks and continues very, very effectively. All right, I'm going to get on the soapbox here for a minute here, which I haven't done too much in this class actually, but and I'll capture these kind of notes as I describe this. Actually, it's like a soapbox alert, right? Is really what it is, right? I mentioned this in CS160 more than in this class, but it's not hard. It's not hard to find coding zealots on the internet, right? It used to be, showing my ancientness here. I would find the coding zealots in the labs, right? The programming labs and the classes and things like that, or on the what were the Usenet servers, right? The news groups. Back in the early internet days. Now it's super easy to find coding zealots all over the internet. StackOverflow.com is the worst. And so some of you may have encountered Stack Overflow when you're like looking for help. You might type in, how do I do this? Or give me an example of this. Or, I see posts on Stack Overflow as blatant as, hey, I have a homework assignment to do this. Can somebody help me? Or maybe a better, I'm trying this and it's not working. But I see these types of things all over the place, and some of you may have taken advantage of internet to get some help, which, I'm totally okay with, by the way, right? The problem with many topics, and I think coding, is near the top of the list here, is, there are lots of people with big egos who think they're the smartest person in the room. It wouldn't be hard probably for each of you to think of somebody that might meet that description. You see this on Stack Overflow a lot. They will almost always say their way is the best way, and sometimes even say their way is the only way. The latter is almost never true, right? There's almost, in programming, there's, I want to say always, but I can't say 100%. There's always multiple ways to do things. And there isn't often very clearly the best way to do things. Okay? But even worse is you'll just run into people who seem that all they want to do is make you feel dumb, right? So I'm pausing on this here because if you're using some of these resources and you run across somebody and you post something and they come down on you hard because you didn't format something right, or you didn't know, oh, you should have used static cast here, or no, that's the wrong way to use this. They need to get over it and don't worry about it. Okay. And so, the reason I'm bringing up this now, right, is it won't be hard to find I'd say you'll easily find examples of people who say there is no use for break or continue in C++. This is a good example, right? I think break and continue is one of those um, zealot attracting topics. And I was just poking around and I was finding, the arguments where people were saying, this is why you should, this is why you shouldn't. Um, they're technically correct. That I'm not sure I can think of an example where you want to use break or continue and you could write it without using break or continue. So technically, I can't think of an example where break or continue must be used. Like I just showed you in that example, right? Where I used continue and I changed it to an if statement. Where I used break, I could also change that, right? It always depends on the application. Okay, so the point, right? The point that I want to make here is when there are multiple ways to implement something, in some case, there may be the obvious better way. Okay, key word here is some. Okay, in all cases, one way might be maybe better than the other, or maybe it just be arbitrary, or maybe it's just your preference, right? And let's talk about what does better mean, right? It could mean faster, right? The program runs faster. Efficient, less, I can't spell that. Efficient, i.e. less memory. I guess speed is also efficiency, right? So it might take less memory. It might be more scalable, meaning you could take that code and use it in other ways. It might be more readable, readable, I think that's right. It might be more readable, okay? And you may only get one or some of these. Hard to get all of them, right? And so this is true, with anything, right? The coding that we're learning here, I'm showing you fast ways to do things, slow ways to do things. In fact, we're not worried about it too much. We don't really worry about it until CS201, for example, where we might talk about efficiency. And computer power is scaled quite well, that it's not going to be until you're getting to really complex programs or things with a lot of data where some of this stuff may matter, right? And so, what I want most of all, right, is in this class, right, is experiment, try, and it's okay if it doesn't work, right? So it's about learn, right? So if you only learn the while loop and when you are running the while loop and you're doing these things and it's kind of clunky and you forget about the fact that you have the do loop, or you forget about the fact that continue exists, that's, maybe it's okay, right? But you always have the chance to learn and make your choices later on. I kept the soapbox to the end here because some of you I'm sure I've lost right now. There is one more thing I want to say regarding the soapbox here. When you are on large projects, mostly in the corporate world, in large teams, and I say mostly in the corporate world, I think this stuff might apply also to large academic projects or open source projects. Like if you contribute to an open source project, when you're on large projects and large teams, there likely will be coding standards and guidelines and rules. Much like the rules that I have in place for this for the code here, where we talk about how to declare variable names, naming conventions, your comment headers, and things like that. So much like the style guide we have for this class. In big corporate programming structures, there's programs that are written to basically make sure your coding follows the rules, right? And in these cases, you'll need to follow the rules, even though some of those rules are arbitrary, right? Should put arbitrary in double quotes here, right? Because, the rule, it could be A or B. Variable naming is a great example, right? In text versus in text versus in text, right? Three very valid ways. And what I say, I don't care which way you use it, I just say be consistent, right? Another good example of this arbitrary rule is the curly brace, right? And so here's an example of the curly brace thing. This happens to be my preference, but other coders do it this way. Some of my students in this class submit code that looks like this. It's fine, but if you mix it, then will make a point about it, right? So again, it's about consistency, and when you're in an environment, it may be required, right? I think that if I was, in charge of a 400-person development for C++, we as a team would decide we would do it this way or this way, and we'd require it, right? And if it was my decision solely, this is what I would pick it this way. Again, my choice. So a little bit of soapbox stuff here as we wrap up this module. It's a good place for it because loops are extremely flexible structures. And now that you've learned conditions, you learn input and output first, and calculations kind of second, right? And then you learn conditions. Without conditions, you can't do much, right? All you can do is do fixed calculations. With conditions, you can do basic testing and basic things. But until you are able to run over and over or process a lot of data, loops with conditions allow you to do almost anything. If you look ahead into the code here, the next big thing is going to be around arrays, and then we can get into some really detailed stuff here, especially as we get into CS161B, right? Arrays in here. We still got functions here, but the data structures is the next biggest thing, right? How do you organize data more than just variables? And as you put these building blocks together, you're able to do more and more complicated code. But loops are a great place to pause at and really spend time practicing. All the stuff we've done, all the very basic things we've done, like guess the number and the run to uppercase the whole string, those are types of things that you can make much more complicated program, right? If you want to reorder text in a document, now you know how to do that. If you want to do proofreading, right? This is how you would do it, right? And so I'd encourage you to practice and again go through those exercises in the textbook here as you prepare to get assignment in discussion 7. For those of you that hung out through the soapbox, thanks. Interested in your perspective as well. So feel free to give me some feedback there, and we'll see you soon. Thanks.